So I'm Suxin from eBay. Today I'm going to give a very brief introduction on how we bid for the Google text ads in Google Paid Search with the help of machine learning techniques. So first, let me introduce how Google Paid Search works. So if you search for something on Google, for example, an iPhone, you will see these two types of ads, the text ads and the product listing ads. For the text ads, they look like ordinary search results, but with a small ad label on it. And for the product listing ads, they are for specific products, and they have the product pictures and product price on the ads. So as you may already notice that there's a lot of advertisers who want to put their ads on Google, but Google has a very limited amount of ad positions. So Google run auctions for these ad positions, and the advertisers just bid for these positions. And Google will decide the winners and show their ads based on the bidding price submitted by the advertisers, as well as the quality of their ads. So as an advertiser, what we want is to bid properly so that our bidding price is high enough to get our ads shown on Google, and not too high such that the cost exceeds our revenue and it doesn't worth it. So from the bidding perspective, the difference between these two types of ads is for the text ads, we bid for each keyword or the search term that the user input in the Google search engine. And for PLA, we bid on each product we have or each item. So today I'm going to show how we bid for the keywords for text ads. Basically, most intuitively, we can adjust the bid for each keyword based on the historical performance of the keyword. So, for example, if the keyword has been performed pretty well and earning a lot of money for us, then we want to bid higher for them so that they get a higher chance to be shown. And for the keywords that performing very bad, we want to lower their bid and move the money to the good keywords. But this is a kind of ideal case. In the real case, we don't have so much data for the keywords. So as the data scarcity problem that is shown in this picture, out of our whole keyword portfolio, only a very small portion of them has impressions, which means they has been displayed on Google. And out of the keywords that has been displayed, only also a very small portion of them has been clicked. And also out of the clicked keywords, a very small portion of them has converted, which means some guy has bought something through the ad of this keyword. So our solution is to group these keywords together according to some metrics and bid on group level, so that within each group, the keywords with no performance are helped by those keywords with performance. So this is our text ads bidding process. Firstly, we source new keywords from the eBay search log using a model called Peach, which evaluates those keywords from eBay search log to discover their potential and put those high potential keywords into the keyword portfolio. So from the keyword portfolio, we bid for every keyword in the portfolio. First, we use this iron model. I'm going to introduce the details. We use this iron model to group the keywords, and we bid on each group according to the historical data on the group level. The lower part of this picture is more detailed, how we group with iron and bid with a bidding algorithm called Brutus on group level. So the structure of the algorithm is that firstly, we predict the conversion rate of each keyword and use the predicted conversion rate and the price of the keyword. Also together with some parameters we learn to predict the revenue we can get for each keyword. Then based on this predicted revenue, we group the keywords into a bunch of groups and use the market-based feedback on group level to adjust the bids on group level. This is the data pipeline. So we use a gradient boosting tree to predict the conversion rate of each keyword, and we feed 3 types of features into the gradient boosting tree to predict the conversion rate. The first is the features from the eBay search data. For example, on the search result page of a keyword, the number of add to cart activities, the number of add to list activities, we use these type of features. And the second type are the paid search performance, which is the number of conversions, the value of the revenue the keyword has been earned in the paid search channel. And we also use the Google features, which are from the Google feedback report, which are like Google quality score for each keyword, the impression share from Google. And we use these 3 types of features to train the gradient boosting trees to predict the conversion rate of each keyword. Then by also considering the keyword price and a parameter set phi that we learned from the data, we estimate the revenue we can get from each keyword. And then we just group keywords according to this estimated revenue and adjust the bid. This is the A/B test result of Iron model. So we run this A/B test for roughly 2 weeks, and in the x-axis, each point is a day, and on the y-axis, the upper one is the cost, and the lower graph is the revenue. Basically, this graph shows, so the red line is the control group, which is our previous model, which groups keywords only based on their categories, with no machine learning models involved. And the green line is the treatment group, which is the error model that we have built. So from this graph, basically we have balanced the cost in the A/B test, and the revenue we get from error is dramatically increased. The ROI, which is calculated from revenue divided by cost, increased by more than 27%. And this is it. It's much shorter. Thank you.